Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is the Pure Mathematics 3 for October-November 2021, and the code is 9709/31. Let's get started. Now for question number 1, solve the equation 4 times modulus of 5x 5 to the power of x minus 1 equals to 5 to the power of x. Giving your answers correct to 3 decimal places. Okay, so first of all, I will rewrite the question. Okay, so for your information, right, the modulus x is defined by minus x when the x is less than 0, or it is x when the x is at least 0. Okay, so from here means that the value inside the modulus can be negative or can be positive. So now I will consider the value inside the modulus be positive first, okay, or the value inside the modulus be negative. Okay, so I will be getting these two expressions. So now the first one is I will just do expansion. So 4 bracket 5 power x minus 4 equals to 5 to the power of x. So this 5 power of x will be moved to the left hand side, becomes minus. So 4 of 5 power x minus 1 of 5 power x is basically 3 of 5 power x. Then this minus 4 will be moved to the right side, becomes positive 4. Then now 5 to the power of x is 4 over 3. Okay, so now to get the x, I will just take ln both sides. So it will be ln 5 power x equals to ln 4 over 3. Now we have a formula here, a ln b equals to ln b to the power of a. Okay, so now you are given the right hand side, just move down the a and you will get the simpler form. So I will get x ln 5 equals to ln of 4 over 3. Then at last, my x will be ln 4 over 3 divided by ln 5. That will be 0.179. Okay, correct to 3 decimal places. That is my first solution. And then my second solution is I need to expand this negative. Okay, so it will be 4 bracket minus 5 to the power of x plus 1 equals to 5 power x. Then I'll do expansion, negative 4 of 5 power x plus 4 equals to 5 power x. This term moved to the right side, becomes plus. So now I will get 4 equals to 5 to the power of x plus 4 times 5 power x, means that 5 to the power of 5 power x. Okay, then from here I need to get the x. Therefore, I move the 5, this 5 to the other side. It becomes divide. Then now take ln both sides. Ln 5 to the power of x equals to ln 4 over 5. Therefore, use the same formula here. Let's ln 5 equals to ln 4 over 5. And hence, your x is ln 4 over 5 divided by ln 5. Then final answer is going to be negative 0.139. Okay, so these are my two x values. So done for the question 1. Now, question 2a. Express 5 sine x minus 3 cos x in the form of r sine x minus alpha, where r is greater than 0 and alpha is in the first quadrant. Find the exact value of r and give alpha equal to 2 decimal places. Okay, so now 5 sine x minus 3 cos x equals to r sine x minus alpha. So for your information, if here is sine, first one must be sine. Okay, because when we do expansion, it will be sine x. Let's say here, sine a minus b. So I will get sine a cos b minus cos a sine b. Okay, that's the reason. So now, once you have obtained the form, then my r is basically just square root of 5 squared plus negative 3 squared. Okay, 5 squared plus 3 squared, I should say 5 squared plus 3 squared. Then here is going to be square root of 34. Okay, then the alpha will be inverse tangent of 3 over 4. 3 over 5, because here 3, here 5. Then you will get 0.54, which is correct to 2 decimal places. And remember, this 0.54 is in radians. Alright, so then my final answer, 5 sine x minus 3 cos x, is going to be square root of 34 sine x minus 0.54. Okay? Now, hence means use the previous answer. State the greatest and least possible value of square of the previous expression. So now, 5 sine x minus 3 cos x squared is basically square of this, right? So, square root 34 sine x minus 0.54. Then I need to square everything. Okay, so from here, the greatest value equals to when the sign is greatest, okay, after you square it. So we know that for the sign itself, sine x will be between 0 and, will be between minus 1 and 1, okay? So then now, it will be 1, because the maximum value for the sign is 1. So here, square root 34 times 1, then you square it. This will be 34. Now the least value, even though it says minus 1 here, but then because of the square outside, so the least becomes 0. So I'll get square root of 34 times 0. And then you square it, it will be 0. Okay, now for question number 3, the curve with equation y equals to x e 1 minus 2x has one stationary point. So stationary points means dy dx equals to 0. Now find the coordinates of this point. Your y is x e 1 minus 2x. Here I will have to use products rule. For your information, d over dx uv. Product of two functions of x, it will be uv prime plus vu prime. Okay, so now my u is going to be x, then my u prime is 1, my v is e 1 minus 2x, my v prime is, now to differentiate exponential function, so differentiate e f x, it will be rewriting the e, then differentiate the power of e, which is f prime x. So now I will be getting e 1 minus 2x, differentiate 1 minus 2x is minus 2. Therefore, the answer minus 2e to the power of 1 minus 2x. Okay, then now substitute into this products rule. So I will get dy over dx equals to uv prime, so x times negative 2e 1 minus 2x plus vu prime, so e to the power of 1 minus 2x. Okay, then from here I notice that the common term is the exponential. So I will factorize the exponential. So e to the power of 1 minus 2x. Then the first term, do expansion, you will get negative 2x. Last term will be plus 1. Okay, and stationary points means dy dx equals to 0. That means now 0 is e to the power of 1 minus 2x bracket minus 2x plus 1. But we know that exponential cannot be 0. Okay, exponential graph is always above 0. So this cannot be 0, which means negative 2x plus 1 will be 0. Hence, 2x is 1. Therefore, your x is going to be half. Okay, and now we need to find the coordinates of the points. Substitute into this y. So when x is half, the y is x e to the power of 1 minus 2x, which means you will be getting half e 1 minus 2 of half. So I will get half e 1 minus 1 is 0. E0 is 1. Therefore, I'm getting half. Okay, so with this, I will get the stationary points with coordinates half and half. Okay. Now, B, determine whether the stationary points is a maximum or minimum. So for maximum and minimum, we need to get the second derivative. So I will rewrite back my dy dx, which is this, exponential times minus 2x plus 1. Okay, and again, my u is an exponential function. My u prime is minus 2e 1 minus 2x. Then my v is going to be negative 2x plus 1. Then my v prime is minus 2. Okay, so from here, my d squared y over dx squared is going to be u v prime. So minus 2e 1 minus 2x plus v u prime. So just multiply. So negative 2x plus 1 multiply with negative 2e 1 minus 2x. Now, substitute the x coordinate in the stationary points, which is half. So when x equals to half, right? So now my d squared y over dx squared is going to be negative 2e 1 minus 2 times half, then plus negative 2 half plus 1, then multiply with negative 2e 1 minus 2 times half. So the first one is going to be negative 2e0 plus this term. Okay, negative 2 times half is basically negative 1. So negative 1 plus 1, this is 0. So 0 times any term is 0. So I will just ignore it. Then from here, I will be getting negative 2 times 1, which is negative 2. When the second derivative is less than 0, that means the point is going to be a maximum point. Okay, so that's the solution of this question. So this is a maximum point. Right? Now for question number 4. Using the substitution u equals to square root x, find the exact value of this integration. So now integrate 1 to infinity 1 over x plus 1 times square root x dx. And you are given u equals to square root x. So this is basically x degree half. Where I need to get du dx, right? You bring down the half, that x with degree half minus 1, which is negative half. Differential x is 1. Therefore, you are getting 1 over 2 square root x. And now you look at here. We have the square root x, and this is the dx. Right? So I will combine, which means I will keep this 1 over square root x. See here, 1 over square root x dx. So this dx will move up, which means the 2 at the bottom will move up to the du as well. So I will get 2 du equals to 1 over square root x dx. Okay, then I need to get the new limits. So when my x is 1, my u is square root 1, which is 1. Okay, sorry, I wrote the wrong limit. This is 3. Okay, so here is going to be 3. So I will be getting, when x is 3, your u is square root 3. Then now, when x is infinity, the u is square root infinity, which means it's infinity. Okay, so now I will change all. So the 3 to infinity will be changed to square root 3 to infinity. Then 1 over. Okay, now the x here. Now, your u is square root x. That means your x is u squared. So I will change to u squared plus 1. And then this green color, I will change to 2 du. Okay. So now I will rewrite. It's going to be square root 3 to infinity 2 over u squared plus 1 du. So when you need to integrate this, then we need to apply another formula, which is inverse tangent. So integrate a over a squared plus x squared dx is going to be inverse tangent x over a plus c. So whereby the a is a constant, these two can be taken out. So when I take out the 2, I will get 2 1 over u squared plus 1 du, which means now my a is 1 if you compare with the formula. Okay, then I will get 2 inverse tangent u over 1, just inverse tangent u, the limits from square root 3 to infinity. And now I will replace the u by infinity first, then I will be getting inverse tangent infinity minus inverse tangent square root 3. So inverse tangent infinity is basically pi over 2. Inverse tangent square root 3 is pi over 3. So when you simplify, this is going to be 1 over 3 pi. Okay, now the next question is number 5. Show that the equation can be expressed as a quadratic equation in tangent theta. So when you see tangent theta means that you must change the cot and cotangent to theta. So for your information, okay, cotangent theta is 1 over tangent theta. Alright, so same goes to the cot 2 theta. So I will write cot 2 theta plus cotangent 1 theta equals to 2. This is plus. So it will be 1 over tangent 2 theta plus 1 over tangent theta equals to 2. And now you need to get quadratic equation in tangent theta, means that the second term I will remain. Okay, and then now for the tangent 2 theta, we have another formula, double angle formula. Tangent 2 theta is 2 tangent theta over 1 minus tangent squared theta. Okay, so here, if I take 1 over here, I have to swap these two. Alright, so I will direct write 1 minus tangent squared theta over 2 tangent theta plus 1 over tangent theta equals to 2. Okay, and then now I will times the whole equation by 2 tangent theta. So the first term will be 1 minus tangent squared theta. Now, since the second term you have denominator of tangent theta, so when you times with 2 tangent theta, you will be getting plus 2. Then the right hand side is 4 tangent theta. And now to get quadratic equation in terms of theta, in terms of tangent theta, all these terms will be moved to right side because I want to get positive tangent squared theta. So the negative tangent squared, you move it to the right side, it becomes positive tangent squared theta, plus with the term on the right hand side, then the 1 plus 2 on the left side, move to right side, becomes minus 3. So this is our quadratic equation in tangent theta. Okay, now B, hence means solve using the previous answer. Exactly the same answer here, or same equation. For theta between 0 and pi, giving your answer equal to 3 decimal places. So now cot 2 theta plus cot theta equals to 2. This can be written as quadratic equation in terms of tangent theta. So I will rewrite tangent squared theta plus 4 tangent theta minus 3 equals to 0. Now, you are not able to factorize this quadratic equation. Therefore, I will use quadratic formula. So the A is a coefficient for tangent squared theta, which is 1. The B is going to be 4. The C is minus 3. For your information, quadratic formula ax squared plus bx plus c equals to 0. Your x is going to be minus b plus minus square root of b squared minus 4ac over 2a. Okay, so now your equation in terms of tangent theta, that means your x now has been changed to tangent theta. So I will get tangent theta is minus 4 plus minus square root of b squared, 4 squared minus 4, a is 1, c is minus 3, then over 2a, a is 1. So from here, you will get minus 4 plus minus square root of 28 divided by 2. Okay, then I will get two values. The first value is using the minus square root 28, and the second value is using plus square root 28. So you will get 0.6458, and the other one is negative 4.6458. And now, when you look at the interval here, your theta from 0 to pi means that first two quadrants. So when my tangent theta is positive, okay, so here, that means my angle is in the first quadrant. So my theta is going to be inverse tangent 0.6458, and you will get 0.573 radians. Now, when it is the next one, so your theta is going to be inverse tangent. Okay, when it is the next one, right, means that your angle is over here. So you need to find this angle first. What is the tangent theta. So I will just ignore the minus sign first. Then you will be getting 1.359. This is the basic angle. I write basic angle. That means this is going to be 1.359. Okay, here, let's say alpha. This is the alpha. But then my theta is the major angle. So my theta is going to be pi minus 1.359. Then you will get 1.783 radians, which means my theta will be 0.573 radians and 1.783 radians. Okay. Alright, so now question number 6. When a plus bx multiplied with the square root of 1 plus 4x, where a and b are constants, is expanded in ascending powers of x, the coefficients of x and x squared are 3 and minus 6 respectively. Find the values of a and b. So now we need to do expansion. This is binomial expansion. So the square root here I will change to degree half. Right? So now I will remain the a plus bx because it's degree 1, and then you need to get coefficient for x and x squared. So it means that here I need to expand up to x squared. So now for your information, binomial expansion is basically a degree n plus n1, a degree n minus 1, b degree 1, plus n2, a degree n minus 2, b degree 2 until b degree n. Okay, that is the binomial expansion when the n is positive integer. So, but now, okay, I used the wrong formula. If let's say positive integer, you are using the formula that I have just shown you. Okay, now if let's say it is real number, you have to refer to this formula, which is 1 plus nx plus n minus 1 over 2 factorial x squared plus until infinity terms. So this formula is valid for real numbers of n. So which means now I will get 1 plus half times 4x, which is my nx, then plus half, which is my n, then n minus 1. Half minus 1 is negative half, then over 2 factorial. My new x is a 4x, so now you square it. Okay, plus dot dot dot. Now, from here, I will get a plus bx, then you multiply with 1 plus half times 4 is 2, so 2x. Half times minus half divided by 2 factorial, then times 4 squared. This square you bring it in, you will be getting negative 2x squared plus dot dot dot. Okay, so now I need to get the term with x and x squared. So it means that my a must multiply with 2x, right? So here I will get 2ax in order to get x, and then to get the x squared, so this a multiplied with minus 2x squared, I will get negative 2ax squared. And then for this bx, in order to get x, I need to multiply by 1, so plus bx. Then to get x squared, multiply with 2x, I will be getting plus 2bx squared. Then, of course, we still have other terms. So from here, I will simplify. Okay, I will group the terms with the x and also x squared. So the first and third term will be grouped together and factorize the x. Then I will get 2a plus b multiplied with x. And then for the other two terms, I will write plus negative 2a plus 2b times with x squared. Okay, then now the coefficient for x is 3. So coefficient of x is 3. That means 3 equals to 2a plus b. That is my first equation. Okay, and then the coefficient for x squared is minus 6 in the question. So coefficient of x squared is minus 6, which means minus 6 is minus 2a plus 2b, which is from here. This is my second equation. Now to solve this simultaneous equation, I can just plus these two equations together because I have 2a and minus 2a. So when I plus together, 3 plus minus 6 is going to be is going to be minus 3. The 2a plus minus 2a will be 0. b plus 2b will be 3b. That means I'm getting my b is minus 1. Okay, then now to get the a, you can either substitute into first or second equation. I substitute into first equation. So 3 is 2 times 2a, sorry, 3 is 2a plus b, which is plus minus 1. So the minus 1 move to the other side because 4 equals to 2a. That means my a is 2. Okay, therefore I found two values. A is 2 and b is minus 1. Okay, now for question number 7. Given that y equals to ln of ln x, show this dy dx. Right, so now refer to the formula. Differentiate ln fx. It will be over fx. Whatever after the ln, you just write in the denominator. Then the numerator is the differentiation of the denominator, which is the f prime x. Now, this is the function after the ln. That means this is going to be my fx now. This is my fx. Okay, then now my y is ln of ln x. Then I will use the formula, this formula directly. So therefore, dy over dx is over ln x, which is here. Then my numerator is differentiation of denominator. So when I differentiate ln x, basically, when you differentiate ln x, it's going to be over x. Then differential x is 1. So I will get 1 over x here. Then after that, you can just move down the x. It will be 1 over x ln x. Okay, so done for the A. Now the variables x and y satisfy the differential equation. Given t equals to 2 and x equals to e. Solve the differential equation obtaining the expression for x in terms of t. Simplifying your answer means that now you need to get x equals to ft. Alright, so now x ln x plus t dx over dt equals to 0. So from here, I will move this x ln x to the other side. So t dx over dt is negative x ln x. Okay, and now I will move down the negative x ln x because your dx is the numerator. Means that I will get negative 1 over x ln x dx equals to integrate the t move down. So 1 over t dt. So when you split the variables, make sure you put the integration signs at the same time. So now to integrate 1 over x ln x, go back to this definition. We know that if you are given y, okay, you see, given y, you differentiate, you get dy dx. So now, if you need to integrate, okay, integrate 1 over x ln x dx, you will be getting the y. Alright, so because it is the reverse process. Alright, so now I will just direct write my answer, ln x, for my integration. But of course, there's a negative outside, so negative ln of ln x. Then integrate 1 over t is ln t, because when you differentiate t is 1, then plus c. Okay, and now replace the values. T is 2, x is e. So x is e, t is 2. Therefore, negative ln of ln e equals to ln 2 plus c. So now here, negative ln e is 1. That equals to ln 2 plus c. Ln 1 is 0. Okay, this is 0. That means your c is negative ln 2. So once you get this, substitute back into this expression. So I will get negative ln of ln x equals to ln t minus ln 2. And then now when you look at the question, you need to find x in terms of t, right? That means the x is a subject. So now my x has, my first term on the left side has negative. So I times the whole equation by negative first. So I times by negative 1. I will get ln of ln x equals to ln 2 minus ln t. And then I will group that 2 ln on the right side by using ln A minus ln B is going to be ln A over B. So here is going to be ln 2 over t. This is ln of ln x. Okay, and then now since you have one ln on both sides, then I can cancel off. That means I'm getting ln x is 2 over t. And now again I have the ln, okay, on the left hand side. So to eliminate the ln, I need to take e both sides, because we have another formula. E ln A is A. Alright, so I have to take e both sides. Then it will be e2 over t. So e ln x is x. Then I will get x equals to e to the power of 2 over t. So that is my solution. Okay, now hence state what happens to the value of x when t tends to infinity. Now I need to rewrite x is e to the power of 2 over t. Okay, so when t tends to infinity, 2 over t will tend to 0. So therefore my x tends to e power 0, which means my x tends to 1 as t tends to infinity. Okay, so done for the C. Now for question number 8. A constant a is such that this integration is 6. Show that a is exponential of 1 over square root a plus 2. So exp x is exponential, right? This is the alternative notation for ex. Okay, so now integrate 1 to a ln x over square root x dx. We need to show that it is this expression. So I will write equals to 6 first. Now, when you need to solve this integration, okay, you have ln, you have 1 over square root x. This is basically, right, integrate 1 to a ln x times x to the power of negative half dx equals to 6. So when you need to integrate product of these two terms, we need to apply the integration by parts. So integration by parts is integrate u dv over dx equals to uv minus integrate v du over dx. And then since we have limits 1 and a, so I will write a and b in general. So then you have to consider limits for all these terms. Alright, so now how do we decide which one is the u? The u is always a ln. Right? If you don't have ln, then the u will be the algebraic. So now your u is going to be ln x. Therefore, du over dx. Whenever you differentiate ln, write down the function after the ln in the denominator. And now numerator is a differentiation of the denominator. So when you differentiate x is 1. And then dv over dx is going to be x power negative half. So your v is integration of x to the power of negative half dx. Therefore, you are getting x to the power of half over half. Okay, because you plus 1. Then now I will simplify this into 2 square root x. That is your v. Okay, so now substitute into the formula u dv dx. uv. So I will get 2 square root x ln x with limits 1 to a minus integrate v du dx. So 2 square root x times 1 over x dx. Limits from 1 to a, then equals to 6. Okay, so now replace the x by a. So I will get 2 square root a ln a minus 2 square root 1 ln 1. Then these two can be taken out. These two taken out. Then the square root x times 1 over x is basically 1 over square root x. Okay, because this is degree 1, this is degree half. Half minus 1 is negative half. So now I will simplify first. A square root a ln a. Now for this next term, ln 1 is 0. That means the whole term will be 0. Now then, the next term, the third term is going to be negative 2. Integrate this is going to be x to the power of negative half dx. Alright, so then you will get x, when you integrate x to the power of negative half, means that now you have to plus 1 to the negative half. So negative half plus 1 is half. Then I will get x power half divided by half. This is your integration. Okay, then 2 square root a ln a. 2 divided by half is 4. And then this is going to be square root. Okay, x power half is square root x. So replace the x by a, square root a, then minus, okay, put a bracket here, then square root 1 equals to 6. So I will write this as minus 4. Okay, and then now I will, okay, you have 2, you have 4, you have 6. So you can divide the whole equation by 2. Then ln square root a ln a minus this is 2. Okay, so this one becomes 2, this one becomes 3, this one becomes 1. Then these 2 times in together with the minus in front. So I will get negative 2 square root a negative 2 times negative 1 is plus 2, then equals to 3. Okay, let's see what you want to prove. You want to prove a is exponential of 1 over square root a plus 2. Okay, so now I will write square root a ln a minus 2 square root a. This move there, it will be 1. Okay, and now because we need to get exponential here, which means before exponential you must have ln a, right? So I need to keep my ln a one side. So square root a ln a equals to 1 plus 2 square root a. So my ln a move, my square root a move down. Ln a equals to 1 plus square root 1 plus 2 square root a divided by square root a. Okay, so from here I can simplify. So 1 over square root a plus 2 square root a over square root a means that it is 2. So now, in order to get a, I will take e both sides. So it means that a equals to exponential 2 plus 1 over square root a. Okay, or 1 over square root a plus 2. So I will just change the order of the two terms. So here it's going to be 2 plus 1 over square root a. Sorry, 1 over square root a plus 2. 1 over. Alright, so shown. Okay, so we have done this part. Now, verify by calculation that a lies between 9 and 11. So I will refer back to the previous form, which is this, and get the FA. So I will rewrite my a is exponential 1 over square root a plus 2. So I move the exponential to the left hand side. So a minus exponential of 1 over square root a plus 2 equals to 0. Okay, and I will let my FA be the terms on the left hand side. Now, to prove that the a lies between 9 and 11, so just use the sign change rule. Replace the a by 9 and 11. Then here you will get 9 minus exponential of 1 over 3 plus 2. That is going to be negative 1.31. This is less than 0. And then followed by F11, which is 9 minus exponential of 1 over square root 11 plus 2. So this is going to be 1.01, which is greater than 0. So you just write F9 less than 0 and F11 is greater than 0. There is a sign change. Okay, hence A lies between 9 and 11. So that is the sign change rule. Okay. Now, use an iterative formula based on the equation in parts A to determine A correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So now our A is exponential 1 over square root a plus 2. So now, to get the formula, iteration formula, add on the subscript. Okay, so now, since your a lies between 9 and 11, so I will take the middle value, which is 10. So I will start with a0 is 10 or a0 is 10. So you can let a0 be 9, 11 or any other numbers in between the two values. So then I will get a1 is exponential of 1 over square root 10 plus 2. Now remember, the iteration 4 decimal places. Then I will get 10.1374. Now, a2 is going to be exponential 1 over square root 10.1374 plus 2. So this is going to be 10.1156. Now, when to stop the iteration? Because your a is equal to 2 decimal places, make sure these two are the same. So obviously they are not the same, then you have to continue for next step. So, and observe. So here is going to be exponential of 1 over square root 10.1156, then plus 2, then I will get 10.1190. Okay, so now here 1190, here is 1156. They are the same two decimal place. Round up by referring to the next decimal place. Since it is 9, right? So we are going to write your A is approximate to 10.12. Okay, so that is the iteration method to get the root. Okay, question number 9. Two lines L and M have equations. So the first one is RL, this is RL, and the second is RM. Now, show that L and M are perpendicular. So, to show L and M are perpendicular, let's say this is L, this is M. That means you have to show the BL is perpendicular to BM. Okay, so I will rewrite my RL is 3i 2j 5k 325 plus s times 4 minus 1 3. Then my RM is 1i minus 1j minus 2k, so 1 minus 1 minus 2 plus t of minus 1i 2j 2k. So now my B of the L, because our formula is I equals to A plus TB. Okay, so it means that this is the this is the B from the first line and the B from the second line. So I will get 4 minus 1, 3, and then BM is going to be minus 1, 2, 2. Okay, so now I get the dot product, BL dot BM, the scalar product, which is 4 minus 1, 3, dots with minus 1, 2, 2. Then now I need to get scalar product, which is 4 times minus 1 plus, so it just times together, plus minus 1 times 2 plus 3 times 2. So the first one is minus 4, second is minus 2, last one is 6. So it means that here the dots product is 0. So when the dots product is 0, means that L is perpendicular to M. Alright, so that is how we prove two perpendicular lines. Now, show that L and M intersect and state the position vector of the intersection point. So, when L and M are intersecting means that the vector equations will be the same, right? So, RL equals to RM. So now I will rewrite this and open the brackets. Then you get 3 plus 4s for the first component. Then the second component is going to be 2 minus 1s or 2 minus s, then 5 plus 3s. So 2 minus s, 5 plus 3s. Then all equal sign. The RM is going to be here. 1 minus 1t minus 1 plus 2t and then minus 2 plus 2t. Okay, so I open the brackets. Then I will get 1 minus t minus 1 plus 2t, then minus 2 plus 2t. So I let this be 3 equations. Now to show that two lines are intersecting, you need to find the t and s using any two equations, then substitute into the next equation for checking. So I'm going to use third minus second equation because I need to eliminate the 2t. Okay, so my left hand side, 5 minus 2. 5 minus 2 is going to be 3. 3s minus s is 4s. Then equals to minus 2 minus 1 means it's minus 1. So from here, my 4s is, right, wait, my 4s is on the left hand side, so the 3 will be moved to right side. So it means that it's minus 4. Then my s is going to be minus 1. So once I found the s, because just now I used second and third equation to solve for the x, now I need to find the t from either the second or third equation. Alright, so I substitute into second equation. So from the second equation, 2 minus s is minus 1, that equals to minus 1 plus 2t, which means this minus 1 move to right side. So initially, move to left side. So initially the left hand side is 3. 2 minus 1 is 3. So 3 plus 1 becomes 4. So 4 is 2t. Therefore, your t is 4 over 2, which is 2 now. Okay, I have found two unknowns. Then I have to show that two lines are intersecting. Means that I have to check the first equation whether they are the same or not, so the left and right hand side. So from the first equation, the left hand side is 3 plus 4s. S is minus 1. Therefore, I'm getting minus 1. Now, for the right hand side, I will get 1 minus t. So 1 minus t is 2. Therefore, I'm getting minus 1 as well. So left hand side is same as right hand side. Means L and M are intersecting. Okay. Now, you need to state the position vector of the intersection point. So for intersection points, you either substitute into the RL, which is here, or you substitute into RM. So it's up to you. Alright, so I will use the S equals to minus 1 and substitute into RL. It will be the same answer. So when S equals to minus 1, my RL is 3 plus 4s. So 3 plus 4s. Then after that, 2 minus s, then 5 plus 3s. So 2 minus s, and then 5 plus 3s. So here is going to be minus 1. The second one is 3, and the third one is 2. Okay, so now let's look at the question, position vector. So my final answer will be in vector. Position vector of the intersection point equals to be minus 1, 3, 2. Okay, now see. Show that the length of the perpendicular from the origin to the line M is this result. Let's say this is your M. Okay, and then this is the O, origin. And now you need to show this perpendicular distance is 1 over 3 root 5. I let the points on the M be P. So means that now let P be the point. Okay, be a point on line M. Right, so now OP is a RM. So now my RM refer back to your equation. That means it's this part. So 1 minus t and all this, right? So I will just write it will be 1 minus t, then minus 1 plus 2t, and then minus 2 plus 2t. That is the RM. Okay, so from the diagram, OP dot BM, this is a BM, it will be 90 degrees. So OP dot BM equals to 0. So now my OP, 1 minus t minus 1 plus 2t, then negative 2 plus 2t, dot with BM. Okay, the BM is basically the coefficients of the t. Here minus 1, 2, 2. Alright, so here I will get minus 1, 2, 2, that equals to 0. Now for the dots product, we need to expand and then plus together. So I will get minus 1 times 1 minus t plus 2 times minus 1 plus 2t plus 2 times minus 2 plus 2t. That equals to 0. So then I will just do expansion. This is minus 1 plus t. Then here is minus 2. This is plus 4t. Then here when you do expansion, minus 4. And this is plus 4t. Okay, so from here, I will get 4t plus 14, 8t plus another t is 9t. So I will write 9t. Then now, minus 1 minus 2 is minus 3. Minus 3 minus 4 becomes minus 7 equals to 0. That means 9t is 7. Hence, the t is 7 over 9. Okay, so it means that when t equals to 7 over 9, you will be getting the point OP, which is such that OP is perpendicular to BM. So now, the question says, show the length. Now I need to find what is my OP, because the length is actually the magnitude of OP. So substitute into the vector OP. So now my vector OP is basically 1 minus t. Okay, minus 1 plus 2t then minus 2 plus 2t, the last coordinate. So minus 2 plus 2t. Then I will get 1 minus 7 over 9 is 2 over 9. Then the next one is going to be 5 over 9. And then the last one is negative 4 over 9. Okay, so now my magnitude of this vector is going to be square root of 2 over 9 squared plus 5 over 9 squared plus negative 4 over 9 squared. Then you will get the answer of square root of 5 over 9. Okay, then this square root of 5 over 9 is same as square root 5 over square root 9. And I will get 1 over 3 square root 5. So that is the magnitude. Alright, so now after this, let's move on to next question, question number 10. So for question number 10, the complex number 1 plus 2i is denoted by u. The polynomial 2x cubed plus ax squared plus 4x plus b, where a and b are real constants, is denoted by px. It's given that u is a root of the equation px equals to 0. Find the values of a and b. So now from here, we know that u is 1 plus 2i. Okay, and then px is 2x cubed plus ax squared plus 4x plus b. Okay, so it's mentioned that u is a root of the px equals to 0, means that now I will replace the u by 1 plus, I will replace the x by 1 plus 2i, and at the same time px will be 0. So 0 equals to 2, okay, the x will be replaced by u. So it will be 1 plus 2i cubed, then plus a bracket 1 plus 2i squared plus 4 brackets 1 plus 2i, then plus b. Okay, so now for your information, if you need to get this expansion, you need to refer to the binomial expansion, or you can use the Pascal triangle. So I will show you both. Okay, this is the binomial expansion until b degree n. Otherwise, because it's degree 2, degree 3 and degree 2, you can just use Pascal triangle. Pascal triangle, you can just consider the coefficients for the terms. So we know that a plus b degree 1, degree 0 is 1. Okay, so if a plus b degree 1, I will get 1a plus 1b. So the coefficients will be 1, 1. Then a plus b squared, the coefficients will be 1, 1. Always write 1 in front and back, at the back. So the middle one is going to be plus. Alright, 1 plus 1 is 2. Then for a plus b to the power 3, I will write 1 in front and back, and at the back. So plus these two values, it will be 3. Then 2 plus 1 is 3. So I found the coefficients of all the terms. Therefore, I will write 2. So the first term is 1 degree 3, because here is 1, right? The coefficient for 1 is 1. Then plus, the next coefficient is 3. So 3, initially degree 3, look at here, degree n. After that, degree n minus 1. So you drop 1 degree from the first term, which means I will get 1 squared, then 2i degree 1. Okay, plus the next coefficient is 3 here. So 3 times 1, then 2i degree 2. Plus last term, the coefficient is 1. So my last term is degree 3. So this is how I make use of the Pascal triangle. And then the next one is a. Now, this quadratic expansion, you will just get 1 plus 4i plus 4i squared. Okay, then plus this 4 just times in. I'll get 4 plus 8i, then at last plus b. So now I will simplify. So it will be 1 cube is 1. So now 3 times 1 squared is 3. 3 times 2, 6. So 6i. Now for your information, here is going to get I squared. So the I squared is minus 1. Okay, this is going to be minus 1. So minus 1 times, this is 4. 2 squared is 4. 4 times 3 is 12. So that means you are getting minus 12. Minus 12 only. The I squared is minus 1. Okay, so then the next term, 2 cube is 8. Then I will get I cube. So now from here, I cube is I square times I. Since the I square is minus 1, so I cube is minus 1 times I, therefore you get minus I. That means I will be getting minus 8i. Alright, so then plus a. So remember, this I square is minus 1. So 1 plus 4 times minus 1, it will be minus 3. Then plus 4i. Alright. Then now last three terms you can just simplify. I'll get 4 plus 8i plus b. Then all this equals to 0. Okay, now I will get the real parts and imaginary part. So this one again to expansion. It will be negative 2. Then this one is going to be negative 12i. Then negative 24. Then here multiply. Negative 16i. Then do expansion, minus 3a plus 4ai plus 4 plus 8i plus b equals to 0. So now I will simplify my real part. Minus 2 minus 24 is minus 26. Minus 26, after that plus 4. Minus 26 plus 4 is minus 22. So I'm getting minus 22 here. So negative 22. And then the term without the I, here and b. Okay, so put them in one bracket. So I will get negative 3a plus b. That will be my real part. So for imaginary part, so now count. Negative 12i minus 16i. I will get negative 28i. Okay, let me check. Then here you have 4a and then 8i. Okay, wait. Now, negative 12 minus 16, I get negative 28. Negative 28 plus 8. So negative 28 plus 8, you will get negative 20. Okay, so let me check one more time. So I'm getting negative 22 minus, okay, let me check back my previous working on this correct. Then plus a, 1 minus 4 is minus 3 plus 4i, 4, okay, correct. So here is going to be, okay, let me rewrite so easier for me to check. Okay, I ignore this step. I simplify the terms inside the bracket first before I do expansion. That will be easier. Otherwise, I have too many terms. It's quite tough for me to check my working. Alright, so sorry about that. So what I need to do here is I will get 2 bracket. Now you see 1 minus 12 minus 11. 6i minus 8i. It will be minus 2i. Alright, so I don't want to do expansion first. I will do expansion later. Then here is going to be plus, this is okay, minus 3a. So I will do expansion here for the next term. It will be minus 3a. Then here is plus 4ai. Alright, then plus 4 plus 8i plus b. Okay, then here I do expansion. So negative 22. Then this is minus 4i. Then after that, minus 3a plus 4ai plus 4 plus 8i plus b. Okay, so then this one looks easier. Now, I will group the real part. So minus 22 plus 4. I will get minus 18. So here minus 18. And then here minus 3a plus b. All this will be my real part. Okay, then for the I will have minus 4i plus 8i. So I will get 4i. So I will take out the 4 and get 4. Sorry, I take out the I and get 4. Then the remaining term is 4ai. So plus 4a. Alright. Okay, so now the 0 on the left hand side is basically 0 plus 0i. Okay, so 0 plus 0i. Then now I compare the real and imaginary parts, which means minus 18 minus 3a plus b is 0. Then 4 plus 4a equals to 0, which means now 4a equals to minus 4. Hence, our a is minus 1. Let this be first and second equations. Now I substitute second into first. So minus 18 minus 3a plus b equals to 0. So this is going to be minus 18 plus 3 plus b equals to 0. So the b, these two plus together is minus 15. Move it to the right side. It becomes 15. So these are the two values, the requested value. A is minus 1 and B is 15. Okay, so done for the first part. Find the values of A and B. Now state a second complex number, second root of this equation. So now since we know that the first complex root is 1 plus 2i, and then the coefficients for the polynomial, the coefficients for the x, right, in the polynomial are real numbers. Therefore, the other second complex roots should be the conjugates of the u. Okay, that's why the question just asks state the second complex number. So it is, just now was the u 1 plus 2i. So now the conjugates will be 1 minus 2i. So I will just write 1 minus 2i. Okay, so now find the real factors of px. So now we know that's the first root x minus 1 plus 2i just now. And then the conjugate will be 1 minus 2i. So now I need to get the factors first. So now I will do expansion. So x squared minus, minus 1 minus 2i times x. Then this expansion minus, again it is minus x brackets 1 plus 2i. Then now, when you look at here, this minus times minus is a plus. Complex number times conjugate. Let's say x plus iy times with x minus iy. So it will be real squared plus imaginary squared. That is the property of multiplication for complex number and its conjugate. So I will get plus. The real is 1, so 1 squared plus 2 squared. So then here I will get x squared, do expansion again together with the x, so minus x plus 2xi. Then here expand, minus x, this is minus 2xi. Then plus 5. Then at last I will get x squared. Now when you look at here, this is minus x, so minus 2x. So you will get minus 2x. Plus 5. So this is my first quadratic factor. And then I need to get real factors. So the other factor can be found using division. My px is 2x cubed then plus ax squared plus 4x plus b. So replace the a and b that you have found. Then you will get minus x squared plus 4x plus 15. So in order to get x cubed from 2x cubed from x squared, I need to multiply by 2x. So 2x times negative 2x will be negative 4x squared. 2x times 5, it will be 10x. Then after that, you minus. So first term will be 0. Second term, minus x squared minus minus 4x, it will be 3x squared. Then 4x minus 10x will be negative 6x plus 15. And then now to get 3x squared from x squared, you need to times with plus 3. So I will get 3x squared. Then minus 6x plus 15. Therefore, the real factors of px will be x squared minus 2x plus 5 and also 2x plus 3. So these two are the real factors. Now for D, first part. On a sketch of Argand diagram, shade the region whose points represent complex numbers z satisfying inequality and the modulus z minus u less equals to square root 5 and argument z less equals to 1 over 4. So z minus u less equals to square root 5. Your u is, refer back to the u, it is 1 plus 2i, right? So this is basically a circle. Circle with center 1, 2, and then radius is square root 5. So now, let me draw the graph. Not graph, the Argand diagram. 1, 2. Let's say here 1, here 2, here 3, here 4. 1, 2. Then now, the radius is square root 5. So square root 5 is basically 2.24. Alright, so 2.24 from 1, it will be 3.24. So here is 3, here is 4. So it will be somewhere here. Let me check. Okay, here x, here y. So this is 2.24. So 2.24 plus 2, it will be 4.24. So this is real axis. This is the imaginary axis. So it will be somewhere here. Right? And then 2.24 from 1, it will be 3.24 somewhere here. After that, 2.24 from 2. Right? Here is 2. That means it will be somewhere here. And then here 2 units, 2.24 units. That means here is minus 1, somewhere here. Now your circle must touching these 4 points. Okay, maybe this is a bit too much. So now let me join. Okay, it is a circle. So make sure you draw a small circle. Okay, so when you measure correctly, right, the circle should touches 0, 0. Okay, the circle should touches 0, 0, 2, 0, and 0, 4. Okay, so please draw this properly. So it means that the circle should be touching all these points. Right, so here I only simply sketch. It's not correct, it's not according to the scale because I also didn't measure it. So it will be something like this. Alright, so that is the z minus 1 plus 2i equals to square root 5. So when it is less equals to means that inside the circle. Okay, now another line is this. Argument z less equals to 1 over 4 and pi. So 1 over 4 pi. So argument z less equals to 1 over 4 pi. Which means our point is 0 plus 0 I. Means that your point is the origin. Okay, make sure your graph, your circle touches the origin. Right, so I need to wait. Okay, means that probably I adjust a little bit. It should be like this. It should be touching the 0, 0. Okay, the graph, the circle touching 0, 0. Okay, so now my point is at 0, 0 and it is 45 degrees. So 45 degrees means that when x is 1, y is 1, when x is 2, y is 2, and so on. So now I will draw a straight line. Okay, and this is less than, here is pi over 4. So obviously your region now is inside. Okay, less than equals to 1 pi over 4 means that it's here. This is your region. Right, this line is argument z equals to pi over 4. Okay, now part 2, find the least value of imaginary z for points in the shaded region. Give your answer in an exact form. Okay, now we need to find least value of imaginary z means that the y value. Okay, so from here, least value, alright, so I will just write least value of imaginary z, okay, is going to be, now, least value of imaginary z is a y. So now, from here, all my points, okay, the minimum y value, it should be this part. Alright, because this is the lowest point. Therefore, here is square root 5. Right, the distance is square root 5. I need to minus square root 5 from 2 because that is the center. Therefore, the answer will be just 2 minus square root 5. Right, so that's all for this video. Thanks for watching. Please subscribe to my channel if you enjoy watching my video and stay tuned for more upcoming videos. Thank you. Bye.